Okay, let's start. Hello, everyone, and welcome to this 1-hour session, The Arctic in a Changing Climate and Its Global Impacts. So this session follows the key findings of the WMO 2024 State of the Global Climate, where we now learned that 2024 is on track to become the hottest year on record. Last year was 1.5 degrees warmer, and we will now learn what kind of impact that has in the Arctic. Because this is bad news for the Arctic and the cryosphere everywhere in the world. My name is Maria Kvalvåg. I am the Deputy Secretary at the Arctic Monitoring and Assessment Program, AMAP. And this session is jointly organized together with the WMO and the Intergovernmental Panel on Climate Change, IPCC. Next slide. So today, we will have a look at the Arctic in the changing climate and the global impacts with 5 presentations, with each 7 minutes. And they are first on the key messages from the AMAP Arctic Climate Change Update Report 2024. There will be 3 talks done by Dr. Rolf Rødven, the Executive Secretary of AMAP, Dr. Jason Box, one of the climate experts of AMAP, and Dr. Heide Silvestre, the Deputy Secretary of AMAP. Then we will listen to WMO and their perspectives of the links between changes in the polar regions and their global impact. It's Dr. Roar Skolin. And then we will hear from Professor Nana Ama-Brown-Klutze, the IPCC author, giving us perspective on the impacts of Arctic climate change on Africa's weather, ecosystems, and livelihoods. So I encourage our speakers to keep their presentations within 7 minutes, so there will be good time to have questions from the audience. And thank you once again for being here. I then will give the floor to our first speaker, Dr. Rolf Rødven. He's the Executive Secretary of the Arctic Monitoring and Assessment Program. He has a PhD in Northern Populations and Ecosystems and an MBA in Strategic Leadership and Finance from the UIT. So, yeah, welcome. Thank you.
Thank you so much, Maria, and good afternoon, everyone. First, I would like to thank WMO and IPCC for this joint event. It's really an honor for us to be allowed to present the first findings for our upcoming Arctic Climate Change Update Report. And it's also an acknowledgement on the emphasis you have, and we all should have, on the Arctic when it comes to its role on global climate change. Next slide, please. Next slide, thanks. Thank you so much. The Arctic Monitoring and Assessment Program, or AMAP, as we'll say for short, is a working group to the Arctic Council. And since the very beginning in 1991, our mandate has been to monitor and assess contaminants as well as climate change in the Arctic and how they impact both ecosystems as well as societies. Also, when it comes to human health issues, as well as how they interact and impact people through a multi-stressor effect. Next slide, please. So the question we could all ask ourselves is, why is the Arctic important? Well, for me, growing up in the Arctic, it is important as it's a very unique part of the world. You don't find the Arctic anywhere else. But also, I would claim that the Arctic is the canary bird of the globe when it comes to the environmental status. There's no such place being affected to such a degree, despite its remoteness, as the Arctic. When it comes to contaminants, it's really a sensitive indicator for contaminants. Even though it's very remote from all industrialized areas, airways and seaways bring contaminants up to the Arctic. They are taken up, accumulated, and magnified through the food webs. And at the very end, the food webs actually is subsistence feeding for the people living there. So they end up in humans, and we do see human health issues with regards to contaminants. Also, when it comes to climate, the Arctic is really the hotspot of the globe due to what we call Arctic amplification. As we will hear later today, the Arctic warms 3 times as fast as the rest of the world. And for some places in the Arctic, we're actually talking about 6, maybe 7 times as fast, like Svalbard, Novaya Zemlya, and places like that. And also, it does have some of the fastest rates of ocean acidification, 3 to 4 times what we see in global or other oceans throughout the globe. And what is really important to remember, as even though the Arctic is really remote, what happens in the Arctic affects the rest of the world. It affects the rest of the world through sea level rise, where Greenland is a very important contributor to sea level rise at the moment. It affects the world through weather connections, as we will hear later about today, through ocean acidifications, and also through societal impacts. Next slide, please. From AMAP side, for a long time, we regarded climate as kind of one of those pressures we were looking into. But now we regard it as one of the drivers for all of the processes taking place in the Arctic. And I'll here exemplify it by contaminants. While we, for a long time, saw very steady decrease in the levels of contaminants in the Arctic, we now see it's flattening out. And for some of the contaminants, like PCBs, we actually now see an increase. And that is partly due to climate change, because climate is remobilizing contaminants through glacier melt, remobilizing those contaminants deposited there, to increase flux between air and sea, to increase river discharge, as well as increased wildfires, as we'll hear more about later. Next slide, please. So we do regard it as an overall driver in all compartments and all the work we're doing of the Arctic. A bit on the background. So when AMAP do our assessment reports are very much done in the same way as IPCC does. So they're actually based upon what you can see on the left-hand side here, like the policy-relevant science questions, which are developed among the policymakers and the scientists jointly. They instruct our monitoring program as well as our work program, and they're undertaken by our experts groups to produce scientific assessments like the climate update, which we will learn about now. We also know, just as any other organization, scientific organizations, that to reach out to policymakers, we need to condense those findings into summaries. So we do produce our own summary of policymakers, which are a purely scientific summary, not negotiated. And added to that, policy recommendations, which are consensus among the 8 Arctic states. Next slide, please. And we've been doing so for quite some time. One of the most impactful assessments we've done actually celebrates its 20th anniversary more or less today. That was the Arctic Climate Impact Assessment, which put the Arctic on the map as this was the first regional assessment showing how climate change impacted the Arctic, but also how that spelled over into on the global scene. At that time, when we introduced that, it was considered as quite radical, because those estimates and predictions we presented were more radical or more pronounced than, for instance, IPCC on sea level rise. However, looking back today, they were actually quite conservative. Here, for instance, in 2025, we regarded, when it comes to snow cover, we predicted a 13% reduction in 2070. We already now see a 26% reduction in snow cover. So we are actually underestimating the speed and impact and extent of climate change in the Arctic. Next slide, please. This is also why we decided to do biannual updates, because we do see that while our typical assessments take 6 to 7 years to perform, climate change is outpacing us. So we decided to do more frequent biannual updates, focusing on key climate indicators that we would just hear about, and for them to be a high priority for brief and rapid information on topics requiring urgent consideration. They are based upon more thorough in-depth assessments, and there are complements to those. So like now, for instance, we are also running assessments on how climate impacts ecosystems and how that feed back into climate systems, as well as societal implications of climate change. Next slide, please. So the report we'll look in today has 7 topical chapters, ranging from Arctic climate change indicators, climate extremes, wildfires, cryosphere, hydrology, ocean acidification, as well as Arctic and mid-latitude weather connections. And for me now, it's my turn to introduce Dr. Jason Box and his presentations of Arctic climate change indicators. So thank you.
They know.
Greetings from Denver.
Nej, vi håller på. Vi ser att vi stressar. Yeah. Okay. So there seems to be some technical issues, so that leaves us with the video later. So let's start then with the next speaker, with Heidi. So she will talk about no video yet? No. Okay. So that we go straightly to a look at the cryosphere, and we'll come back to the key indicators after that. Heidi will talk about the changing cryosphere in the Arctic and its global impacts. And Dr. Heidi, she's also a Deputy Secretary at AMAP, an internationally renowned glaciologist, a leading voice in climate advocacy, and a member of the Explorers Club. Heidi's research focuses on Greenland ice sheets and tropical glaciers in Uganda at the moment, in collaboration with UNESCO. So Heidi, the floor is yours.
Thank you so much, Maria, and hello everyone. Great to see so many of you here. So let's get started. As a glaciologist, the cryosphere is very close to my heart, so there will be many, many slides about what's happening to the snow and ice regions of the Arctic. Cryosphere changes are really profound in the Arctic. Every part of the cryosphere is responding to climate change. For example, sea ice that covers permanently the Arctic Ocean. This ice is actually vital, not only to cool down our planet, but also to maintain the stability of the entire climate system. Sea ice has an annual cycle It grows during the winter, during the spring, reduces during the summer months, and we often take September as a month of reference to have an idea of the health of sea ice in the Arctic, and it has been declining a lot. As you can see, since we've had satellites, it's been declining about 60, almost 60% around the months of September in its extent. Snow cover, as Rolf explained, is also massively reducing, and permafrost, the frozen ground, that is not only helping the infrastructures of the Arctic, it is the frozen ground, so we build things on it, is also responding highly to climate change with increasing temperatures. Speaking of permafrost, the more permafrost thaws, the more soil is easily eroded. This contributes to erosion of our coastlines. It also contributes to affecting the 66% of the Arctic infrastructure that is built on permafrost. It's a huge amount. But also, as you know, the more this frozen soil thaws, the more it emits greenhouse gases. And this is a huge problem. So at the moment, we're seeing a significant increase in greenhouse gases coming from permafrost thaw. But also, as Rolf introduced, permafrost is kind of a freezer for contaminants, for pollution that has been emitted further south. And the more permafrost thaws, the more these contaminants and pollution is being released. That includes mercury. So the impacts are extremely strong, not only on the millions of people who live in the Arctic, but also it goes way beyond the Arctic regions. Coming back to sea ice, I have a little animation here showing you how quickly sea ice has been responding to climate change. This is a video that you can find on the NASA YouTube page. Sea ice has not only seen its extent reduced by 40% since the 70s, but also the volume of Arctic sea ice has reduced by 3/4 since the 70s. And as you can imagine, if sea ice disappears, it can have dramatic consequences on the entire Arctic region. Not only we will lose this white blanket covering a very dark ocean, that will mean that the dark ocean will be able to absorb solar radiation very readily and redistribute this heat all over the Arctic, catalyzing the melting of Greenland, catalyzing the thawing of permafrost. But also, there is a really state-of-the-art topic of research at the moment that says, what will be the impact of the loss of Arctic sea ice on the rest of the world? On ocean circulation, on the winds across the world? This is still a very controversial topic, but there are definitely some studies that show that if we lose Arctic sea ice, this might have an impact on the polar jet streams. This might cause, in turn, extreme weather events further south. But we need more research to really understand how all of this works. And I want to show you, some of these examples, why actually the Arctic is much closer than we think. So everything that's happening in the Arctic can affect the rest of the world. This was, for example, the beginning of September with a really strong cold wave traveling south that created insane precipitation actually all over Europe, all across different countries with massive, massive floods. So to continue on the path of cryosphere, I think the clicker doesn't work anymore. Oh yeah, here it is. The polar oceans are really key pillars of our climate system. If you look at the Arctic Ocean, for example, it is obviously made of very cold water, as you can imagine. And cold water is very good at dissolving CO2. So these polar oceans are some of the best carbon sinks we have on Earth. This is, something that's very, very important to understand. But the fact that they are being these really efficient carbon sinks comes at a very high price. It means that their waters are becoming more and more acidic. As they are becoming more and more acidic, this is having strong implications on the entire food web that lives in the oceans. And of course, in turn, fisheries are suffering, livelihoods are being impacted. So we really need to decide, how much do we really want to preserve the quality of these waters for not only the marine food webs, but also people who rely on the health of these oceans. Continuing on the path of cryosphere, some updates about what's happening to the freshwater systems of the Arctic. What we're seeing is that obviously there is more and more fresh water being mobilized in the ecosystems with an increase in water discharge. The more we bring fresh water into the salt waters of the Arctic Ocean, the more this is having an impact not only on the ecosystems, but also on ocean circulation. We're also seeing an impact on the ice forming on the lakes of the Arctic during the winter months. Ice on lakes is extremely important for indigenous and local communities. You know, they use lakes and rivers to just move around during the winter and spring months. And so it's unfortunate to see that this ice is also suffering tremendously. We're also having more and more rain falling in the Arctic that totally affects the rest of the ecosystems and, again, livelihoods in these regions. Even though this is not cryosphere, I must touch a word on what's happening to wildfires. We're seeing more frequent, more extreme wildfires in the Arctic. This is having obviously terrifying consequences on the ecosystems, but the rest of the world is also being impacted by these wildfires as they release huge amounts of black carbon and huge amounts of greenhouse gases. So as you can see, the number is really frightening, a four-fold increase in wildfires in the northeastern Arctic between 2003 and 2023. What about the overall warming of the Arctic region? Well, we expect again that the warming will only increase in the Arctic in the years and decades to come. If this is proven right, we could have a potential ice-free Arctic in the summer by the decade of 2040. I just want to let that sink in. This is very, very soon. And again, we expect more extreme extremes, especially more extreme rain events in the Arctic region. So to conclude this part, I would like to say that if we lose the Arctic as we know it, we lose the world. And this is a quote from the former Finnish president. And I think this is very true. I think we've all kind of forgotten further south, actually, how important the Arctic is to our daily lives. You know, the food we eat, our health, the stability of our climate system, all of this is connected to the Arctic. And at the moment, this is really one of the regions that is changing the fastest on Earth. So we must do everything we can to continue doing the best possible science in this region to be able to anticipate the changes that will affect us. Thank you very much.
Thank you so much, Heidi, and for presenting these new findings from the AMAP Climate Update Report. We will just have a 1 minute short break so they can fix the video, and so we will all be looking at the video in one or 2 minutes. So just bear with us with these issues, and we'll be right back. Thank you so much. They needed the screen to test it, so they just wanted us to have a break. Oh, no problems.
Greetings from Denmark. I'm Jason Box. I'm a professor
That was
in
fast. Thank you
glaciology
so
and
much.
climate at the Geological Survey of Denmark and Greenland. I wish that I could be there in person with you to discuss the many climate issues at COP29. And this will just have to do this video recording where I'll be sharing the Arctic Monitoring and Assessment Program's most recent compilation of climate indicators, climate issues of concern for the Arctic. I'll switch now to a presentation mode, and professor in glaciology. Greetings from Denmark. I'm Jason Box. I'm a professor in glaciology and climate at the Geological Survey of Denmark and Greenland. I wish that I could be there in person with you to discuss the many climate issues at COP29. And this will just have to do this video recording where I'll be sharing the Arctic Monitoring and Assessment Program's most recent compilation of climate indicators, climate issues of concern for the Arctic. I'll switch now to a presentation mode. And thanks for tuning in, and have a great COP29.
The Arctic Monitoring and Assessment Program is constantly updating its observation-based indicators to evaluate how Arctic climate is changing. You can see this is a large international group that puts together this, and with the latest AMAP report coming out, here is what we have learned. The Arctic is warming up about 3 times faster than anywhere else on the planet. The action is around where sea ice decline is the greatest. The the small trend here, no trend, is where the ice is thickest. Greenland is warming about 1.5 times the global rate, whereas the Arctic Ocean is warming up to 7 times the global rate. The main product that I've been working on is assembling these multi-indicators. So let's walk through these. We have temperatures on the upper panel here. The black line is global, the red line is Arctic. Again, about 3 times global Arctic warming. Arctic amplification, there's a number of physical mechanisms that produce that, mainly the loss of snow and ice cover, the release of heat from the oceans. The blue line is a deep Greenland ice sheet temperature. You can see how it closely tracks the Arctic temperature change, a completely independent indicator. Precipitation, it's a wetter Arctic. We have 2 different data sets here. The time axis you can see down below is 1971 to present. It's from 1979 that the highest quality measurements we have, mainly from satellite, are from. So we have an increase in the precipitation in the Arctic, a wetter Arctic. You can see the disagreement between these. It's difficult to estimate, but what we can be sure of, in my opinion, is a wetter Arctic. River discharge slightly increasing, 13% over this period of time. You can see most of the rivers in the Arctic are exiting from Eurasia, and the Arctic Ocean is just 1% of global ocean volume, yet receives 5% of river discharge. So it's a kind of a freshwater hotspot. And so you have a freshening of the Arctic Ocean also from the melting glaciers. The tundra greenness, and depending on 2 different metrics, we have a greener Arctic at the same time that the woody stems are increasing. So temperature and precipitation explain this increase. The fire activity is much more sporadic, but we've had some record-setting fires like in 2020. The conditions to promote fire weather are actually quite straightforward. We have more lightning ignition. That's the main trigger of this. And so warming enhanced lightning ignition of fires. Snow cover decreasing. Now, May to June, this is before the Arctic sea ice decline. And so snow cover represents a very important factor, declining on land, and then you have Arctic sea ice declining. We assessed glaciers, including Greenland, and Arctic land ice is the largest single contributor to global sea level rise, with Antarctica, much larger, is trailing even Greenland. So the Arctic is a hot spot of change. And in one graphic here, we can tell a lot of stories. These are all based on observations. Some maps that show the wetter Arctic, mainly over the oceans, and less snow cover, with the exception of more snow cover around southeast Greenland. And so the less snow cover, less snowfall in the North Atlantic is really because more of that precipitation is falling as rain, as the threshold of temperature it increasingly crosses the 0 degree, and so you get more rain instead of snow. And okay, the expectation of a wetter Arctic is totally in line with basic thermodynamics, because the warmer air can hold more moisture. And I already did mention Antarctica here. I was expecting Antarctica to be catching up to Greenland, and I think someday it will. These are the sea level contributions, but for the time being, Greenland remains the largest single cryospheric source of global sea level rise. And its peripheral glaciers are where a lot of the losses are occurring. Alaska, you can see, is losing ice almost as much as Antarctica. So Alaska is a huge hotspot. And ICE, it tells a story. So we have only to listen to the story that ICE tells. And with that, I thank you for your attention. I wish you a very productive COP29 meeting. Have a good day.
Greetings from Denmark. I'm Jason Box. I'm a professor in glaciology
Okay.
and climate
Thank you
at
so
the
much.
Geological Survey.
So that concludes the presentation of the upcoming AMAP climate report. So this is actually a pre-launch of this report. It is now under layout. The peer review it had finished a few months ago, so now it's into layout and will be officially launched in January at the conference Arctic Frontiers. It's dated January 27. So then it will also be coming with a summary for policymakers with recommendations to policy on how to act on these important findings. So then we can move on to our next speaker today. It's Dr. Roar Skolin. He will talk about a WMO perspective on the links between changes in the polar regions and their global impacts. He is the Director General of the Norwegian Meteorological Institute and the co-chair of the panel on polar and high mountain observations, research and services of the World Meteorological Organization. So the floor is yours.
Thank you very much, Maria, and good afternoon, everyone. So as Maria said, I am affiliated with the Norwegian Meteorological Institute, but I will speak here today in my capacity as co-chair of this fourth panel of WMO. First of all, I would like to thank AMAP for doing this assessment and for collecting all this valuable yet scary information. It's very important for us at WMO to have these facts available and to build on them when we talk to other leaders. So what's our perspective on the changes in the polar regions and especially their global impacts? You have already heard some of this. Global sea level rise is perhaps the biggest problem. And the small island developing states are at the forefront of experiencing that. In fact, when we talk to the other director generals in WMO, those that help us the most is the directors of the meteorological services of the small island developing states, because they are close to equator, but they are the ones that experience the sea level rise. Permafrost is thawing, and you've heard today, and Heidi also gave an excellent presentation yesterday showing how much greenhouse gas emissions that contributes to, and that of course gives additional global warming. Sea ice was also mentioned here, and sea ice reduction of sea ice lead to additional global warming because the ocean becomes black instead of white. And we will have more extreme events in Arctic. And as Heidi also said now, one of the big issues is how will the changes in the Arctic impact weather globally. So currently, Greenland and the Arctic are the main contributors to sea level rise. Antarctica is, of course, has much more ice, but at this point in time, it's the Greenland and the Antarctica that contribute the most. The challenge with changes in the cryosphere is that it's largely irreversible. It's going to take us hundreds of years to get that water back into ice. That's the message that we are trying to get through. Temperature we can reduce again, but it's very hard to get that water back into ice. So at the WMO, we work, I would say, on two levels. One is the very high level, and one is a very practical level. I'll start with the high level. And this year, at the Executive Council in WMO, we agreed on 4 high-level ambitions. Sorry for the numbering here. It should be 1 and 2. So the first one is that everyone on the planet is prepared for and resilient to the impacts of changes in the cryosphere. So we know that they will be coming. We need to adapt. We need to prepare as best as we can all around the globe. And we need, as a community, to work collaboratively to limit and reduce cryosphere loss and its impact. And we know that the only way to do that is through mitigation. And then we have number 3 instead of 3 and 4. So this should be 3 and 4, clearly. Data, science, and indigenous knowledge should be accessible and provide the sound basis for policies and decisions relating to the cryosphere. And here, your work at AMAP comes into play. We need to know what's happening with the cryosphere now, and we need to know how the cryosphere will react to further warming. And we do not have all the data and the related science that we need for that. Finally, the importance of the cryosphere and the consequences of its changes are known, universally understood, and inspire action. So that's pretty much what we as directors do. We try to talk to all the leaders to get them to understand what the cryosphere is and the implications of the changes to the cryosphere. Yesterday, I learned that the Norwegian Prime Minister now knows what the cryosphere is, so that's good. Then on a more practical level, what WMO is doing operationally is that we have a global network of observations covering the whole globe. It has some gaps, and one of the gaps are in the polar regions and also the high mountain regions. So we try to build better observation systems together with our members in the Arctic and in the Antarctica and also in the high mountain areas. And we would very much like to encourage all the parties here at COP to agree on closing the gaps in observations through the mechanisms that we have. One of them is the Systematic Observing Financing Facility of the UN. And we encourage satellite agencies and funding providers to foster operationalization of satellite observations over ice and snow. However, there are a number of observations already available. The challenge is that these data are not shared. There are many research organizations operating both in the Arctic and the Antarctica. They collect their own observations, but they are not necessarily globally shared. So what we will do is to foster more collaboration on systematic observations in the high mountains and polar regions in order to get them shared with researchers and with operational institutes. With that, we will advance the predictivity capacity of our climate models and increase the confidence in understanding of impacts associated with changes in the cryosphere. So we will try to pursue a dialogue around the research about the cryosphere under the climate change and the associated global impacts at the 17th meeting of the research dialogue of SUBSTA. For the cryosphere, every 1/10 of a degree of warming counts. The amount of ice that melts with 1/10 more degree warming will have implications for us all, no matter where on the Earth we live. Thank you very much.
Thank you so much for those very important words. Our next speaker is Professor Nana Ama Brown-Klutze. She is the vice chair of IPCC's Working Group 1 for the 7th assessment cycle. She was also a lead author of the 6th assessment cycle of the IPCC, and she is the professor at the Department of Physics at the University of Ghana. She will talk about the impacts of Arctic climate change on Africa's weather, ecosystems, and livelihoods. So the floor is yours. Thank you so much for being here.
Thank you and welcome once again. So I think we have heard it all, and the Arctic melting of the ice and the Arctic melting of the glaciers, it's evidence. You have seen many of the presentations talking about that. There are so many consequences that the melting is also bringing. I will not go into the physics, the changes in the albedo and the effects that it brings has a lot more to do with the earth energy budget as well. So we'll not go into that, but simply um, melting of the ice means also the release of carbon dioxide into the atmosphere, because it also serves as a storage for carbon dioxide. It comes also with heat wave intensification, because it's also contribute to the cooling of the earth. But then if we're losing it, it means we're going to have the warmth, and again it falls back to the earth energy budget. This melting also has impact on the monsoon system. And in Africa, we have the West Africa monsoon system that controls a lot of the climate system in Africa. It also controls the jet stream, or it has influence on the jet stream, where that's influence on wind patterns, and it has everything to do with humidity and weather patterns in Africa and West Africa. And the biggest of all of this is the sea level rise, which is the impact is very common, very usual in many coastal cities around the world. This, you might have seen it in different ways. This is from the IPCC state assessment report. And this is a observation, seeing how the sea level is rising over these years, and it's rising faster than we actually expect, and it's because of the melting, largely because of the melting of the ice at the Antarctic region. So Africa's vulnerability is because Africa has a big coastline, and I highlighted a few studies that is doing the coastal studies due to sea level rise. You can refer to them. That's the latest one here. And they have been monitored. All the coastlines are being monitored around the African region, and specifically highlights this from West Africa, where I come from, in Ghana, where I come from. So the vulnerability index is being calculated, and it shows clearly how much the sea level rise will affect the people and the livelihood of the people. I show this is Madagascar, and you can clearly see how much we're losing the land mass of Madagascar. It's a very small area in Africa. So these are coastal cities, and very specific cities in the coastal region, and the effects of the sea level rise. So these are coastal erosion. I particularly lived in a coastal community, and I've seen it for myself, the evidence of coastal erosion. So this is coming from the Albatross projects, where they have recorded most of the evidence of the destruction that we are having at the coastal lines in along mostly West African cities. So you can see that the houses were not built very near to the ocean like this, but then eventually we have, because of sea level rise, the ocean has come that close, and it's affecting uh, properties and livelihood of the people. So many areas around the coast. I see that in the Sea assessment report, we have also projections of the sea level rise. And it's clear that this is not going down, it's only going up. The sea is continuing to rise. And in the business as usual scenario, it's going to be more devastating. And there's one thing for sure causing all of this melting, not working. One thing for sure, I use the boiling frog fable to explain the situation that we are in, and the attention we are paying to climate change issue. So the baseline is global warming. As the temperatures are increasing, we are losing the ice cap, we are losing the glaciers, and then we have the consequences thereof. We all know how the whole world took to the urgency of COVID-19. The whole world woke up to the pandemic and everybody did something. Either you pay attention to the instructions or you went into getting vaccines or not traveling, or we all paid attention one way or the other to making sure that we are where we are today without the pandemic or less effect of the COVID-19. That is not the same attention we are paying to global warming. So we are having the effect at the moment, and then we are only adapting. We're not doing much of the cut of the emissions because we clearly, the IPCC has also clearly attributed the warming to humans' contributions. But then that's all we are doing. We still talking, but not doing much of what we are supposed to do. So we continue to be adjusting and adapting and finding ways to manage the situation. And then before we know, we boil. So if you put a live frog in a hot water, it will jump out immediately. But then if you put the same live frog in a water of its normal condition and you apply heat slowly, it will try to adjust. So it will move from the maybe below the pan to the little bit the top beside the pan to a little bit in the middle, trying to adjust, and then before it knows, it has boiled in the water. So I believe that we can pay much attention than what we are actually doing. If we can put in the effort we had put during the COVID-19, same level of attention to climate change issues, I believe that we can have a better world. Thank you very much.
Thank you so much. So we will go to the next on the program, which is the questions and answers. So I would like also to you, Nana. Yeah, please. And then the three of you, please take a seat here at the front. And there will be about 15 minutes or so for questions from you in the audience. So please, are there any questions to these experts on the cryosphere?
Yeah, thank you very much indeed, the presenters. I'm really excited to listen to all of you. And really what comes out prominently is the interdependency and interconnectivity of our global planetary systems. And now look at it very clearly, from Arctic to Africa, particularly West Africa. But now I think the question that I'm throwing to all of you, I think one of you clearly mentioned that the way out is mitigation. But now looking at the pictures that Nana has just showed, it means adaptation, because you're talking of the industrialized countries, especially as far, the countries that you mentioned, Greenland, Finland, Denmark, and others. But then for us in Africa, it's all about adaptation. But now while you are emphasizing mitigation, we are asking for more community policy, nature-based driven solutions, possibly through adaptation, not for Africa, not necessarily mitigation. But I'm not contesting the fact that we all need to do something. So the questions after setting this scene, the questions to all of you is then, where is adaptation in the context of your presentations? Thank you.
Thank you. Do you want to start, Rolf? Yeah.
I can start, and I guess there's a lot of us that would like to add in on that. The one does not come without the other. I mean, whatever. If we were able to, cut all greenhouse gas emissions right now, the heat will still be rising due to all of the heat stored in the oceans and so on. So we will see the melting of the Greenland ice sheet still going on for some time. So adaptation comes in combination with mitigation. So we can't do one without the other at the state we are now. So, and that's also we've been stressing also for the Arctic regions, because I mean coastal erosions, as you saw, is happening at very high speeds in the Arctic. We're talking about 17 meters a year. And it's not only affecting the future generation, but it's also affecting past generations. We see graveyards being washed out in the sea. So adaptation is necessary at the speed things are happening now, but it has to come in combination with mitigation. Otherwise, we will keep on adapting till there's nothing more to that. Thank you.
Yeah, I like to be more practical. So let's say we have water here, and it's because a tap is opened, whatever reason it's open, but there's water here and distracting us. So whilst we try to lift our feet off the water, you also want to tackle the source. You want to turn off the tap. So the process, moving from your seat to turning off the tap, is the mitigation we want to do. But whilst you want to turn off the tap, you still must survive through the system, I mean, the event. So as he said, we have to do the two hand in hand. But then I feel we are not being sincere also as people. We talk, but then the mitigation effort is not enough. I feel that we could be more ambitious, we could do more, but we are not doing what we have to do. And that is, I think COP should, be more intentional about being ambitious about the mitigation efforts. Yeah, thank you.
My addition to this would be, this is what we are saying now is kind of an early warning in terms of sea level rise. While the number now is 2.8 millimeter or whatever per year, it really doesn't matter. What matters is that we have already committed to 1 or perhaps even 2 meters of sea level rise with the emissions that we have today. And that is what we have to prepare for. We have some time, but we need to start now because it's going to be extremely expensive and take a lot of time. And as you saw from Nana's pictures, it has already started, the erosion has started. So we need to start adapting to what we have already committed to of sea level rise.
Yeah, thank you very much for your question. I think your question is also strongly tied to the tipping points of our climate system. And when it comes to the cryosphere, this is certainly a very, very big topic, because the latest science is showing us that Greenland, for example, that holds enough ice to increase sea levels by 6 to 7 meters, might start to collapse irreversibly when temperatures reach around 1.5 degrees. It will take a lot of time to figure out whether or not Greenland is starting to collapse, but it seems that the first domino of the entire chain might start to fall around 1.5 or slightly above. So that needs to show us that our capacity to adapt will become harder and harder the more we cross these tipping points. And as long as we don't stop the tap, we will not manage. We will reach a point when everything is changing too quickly for us to adapt. But you also mentioned, and I really like this, nature-based solutions. And I mentioned very briefly that the polar oceans are some of the best carbon sinks we have on Earth. We desperately need to help our carbon sinks. In my country, in France, for example, our forests have seen their capacity to absorb carbon divided by two. Can you imagine? So if we don't continue to conserve these ecosystems, we will not manage. So absolutely, we need to decarbonize, we need to help nature, and we need to understand that our capacity to adapt will be pushed really, really far in the years and decades to come.
Thank you all for that good answers. Are there any more questions from the audience?
Thank you. You mentioned the S-ROC reports. Because it's dated back to 2019, you say that this really big report, they take a lot of time, they're really time consuming. Are you aware when there will be a next large report like that with the IPCC?
Maybe that goes to Nana, or?
Want to answer?
Well, I think it will come in generally under the seventh assessment report because we have only one special report, which is the climate change and cities under the seventh assessment cycle. And so assessment in that form will come under the bigger report of the AR7, the main report.
So around what year? Which year?
Oh, the cycle has already begun, and we're actually going to Kuala Lumpur in December for the scoping of the seventh assessments, and then after the scoping, we send out the topics by experts, the areas of um, discussion to governments and also experts for review. So you should look out for those and then make your comments as much as possible. And then government will meet to approve. And then we call for authors, lead authors, to write on the specific topics. So if you're particularly interested in an area that the IPCC should be looking at, you should talk to your expert in your country or talk to your government representatives in your country, and also look out for the report and make comments. Or at every stage, we send it out for expert review.
Okay, thank you.
Thank you.
Yes.
And I suppose the reports are suspected to be published in 2028, right?
Yes, yes, the time, yeah.
If I could just add in on that question with regards to our cycle. So as I showed in the beginning, we will do our next climate update. At least we plan to do so in 2 years. But in parallel with that, we do run one larger assessment on how climate affects Arctic ecosystems and how that feedback through the climate systems, for instance, through reduction of albedo, carbon uptake, and so on, which kind of, it's really one of the black boxes we have in Arctic now. Like, is the ecosystem able to dampen or will they accelerate the climate change going on? And likewise, we look into societal implications, and we'll try to. I mean, we also feed this into the IPCC to ensure that Arctic is on the agenda, even in between those cycles of the special reports.
Thank you. Are there any more questions from the audience? I have one question. So the WMO State of the Climate report says that last year was 1.5 already above pre-industrial times. And now we heard that the Arctic is warming 3 times the global warming. So can you reflect a bit on your thoughts on this and how you believe it will be?
Maybe I can get started. I think it's such a good question. And speaking, tying this back to the notion of tipping points, what really matters for tipping points is not only the peak temperature, but also how long we will be at this temperature for. And there's a paper that came out about this just a couple of weeks ago that says, okay, for Greenland, it might take actually a couple of decades above 1.5 to re-trigger this tipping point. But things are not going in the right direction. I mean, let's be very honest. It's getting worse and worse. And again, if we do not stop extracting and burning fossil fuels, we will not manage. If we do not continue giving the funds to be able to mitigate and to adapt, it will become increasingly difficult for humanity. And sadly, it's always the most vulnerable populations that will be the most impacted. So, I mean, we're always hoping for the best for this COP, but we shouldn't forget the importance of mitigation, and also it's a finance COP of having the funds to do it and to adapt.
Anyone else?
Well, if you look at how the Arctic is changing, it's very frustrating to go up there and see what it's like now. Areas that used to have complete snow cover during the whole winter now varies between temperatures above 0 and below 0. So it melts and frozen, and you get ice. People cannot live the way they did before. So the Arctic is really we can see up in the Arctic what's going to happen in the rest of the world because it goes so fast in the Arctic. And it's really
degrees Celsius warming means 2.5, 2.4 for Africa already. So that's a global average. So, but for Africa, it's much higher, warmer, and is, I mean, equally affecting a lot of things: the soil moisture and agriculture and so many other things. So that's just for us to be thinking through. Yeah, thank you.
Just to and this, I mean, what we heard is the warming as it takes place now will change the Arctic for a long, long period of time, maybe irreversibly. And for me, this has a personal side. I grew up there, and I have my family living up there. And for me, it's also, I know that I will not be able to show my daughters my home as it was to me, because it's already not existing in the same way, and it will turn much worse. And but it's also for them. It's all for them. It's worth to continue communicating this, continue to communicating the need for action on this, for not for only my daughters, but for all of your daughters and sons and grandchildren and so on, because this will impact them tremendously at some point in their life. Thank you.
Thank you. And I was also thinking the other day that people that are, or babies that are born today, they will probably live in year 2100, right? So it's not so far away. It's our kids that will grow up in that world. Okay, any more questions? We have 1 more minute. Otherwise, we will just... One more for you? Yeah? Sure.
Thank you for the opportunity. I'm curious about, you're saying that it's changing so fast. I'm curious how your science, the way you're doing science, has also to adapt to how fast it goes. Thinking, for example, about the fact that marine communities are changing so fast that you have to adapt also the way you're looking at them, like the organisms are changing. So how do you have to change the way you're doing science according to that?
That's a really good question, and we could talk for hours about that, but I'll try to be quite quick. What we see now in the Arctic is, I mean, whatever knowledge you're talking about, we always talk about knowledge when we look on data in retrospect. So whether we talk about indigenous knowledge, whether we talk about science, we always try to base our models on what we know. But to a large degree, we are pushing the system to the very end of the reference frames. So we are really, I mean, talking about tipping points. Tipping points are really hard to predict because it's an irreversible, non-linear mechanism. We've never been on the other side. So we're trying to predict something that we haven't seen. So what we are trying to do from our side is to kind of, as Ruar mentioned, combine monitoring system, combine knowledge systems. So we are trying to work integrated with indigenous peoples to combine their knowledge with where we monitor and do the science to see if we're able to increase the resolution and increase our understanding of the system.
Thank you for that. And for that, we would like to conclude and AMAP WMO. Okay.
Yeah, I just want to invite you. So based on this issue of tipping points, so we're thinking of new knowledge, new science, technology, artificial intelligence, and new policies, and our efforts and agency we need to move. So the IPCC will have a vision presentation here tomorrow, I think from 10 a.m. And so you can come and participate and listen to the direction we're going from IPCC perspective on this new science tipping point and the way we need to go. Thank you very much. Thank you.
Thank you for that information. That was very good. Okay, so thank you all for coming, and I want to thank WMO and IPCC and AMAP for jointly having this session, and have a great COP. Thank you.